Next topic is for lecture 5 is two-dimensional surface. In general, any shape of the inclined submerged plane surface, a point at depth h is the dA. So dF is equal to gamma h times dA. Okay. So that is the dF, and is from dA is gamma h times dF is equal to gamma h times dA. Okay. And for the total force acting on the inclined plane are summarized. Summation of force acting on dA is because the FR integration of the first equation. Okay. And you can look at this is the indication of the YdA. Okay, indication of YdA is the first moment of the area. Okay. And for FC is because the location of the centroid of the x-axis. Okay, in this case we can show that what is the YC. That is a YC. Okay, that is this point is the centroid of the area, and this is YC. And for HC and YC we can find the connection between HC and YC. Okay. Next, we can find F resultant force equal to integration of y sine theta dA. And if we substitute this equation, use above equation, okay, so we got the gamma sine YCA. Okay, and in this term is equal to HC equal to YC sine theta based on figure below. Okay, so we can prove that for the resultant force is equal to gamma HC times area. Okay, so once we know FR, in this case the sine of the FR is equal to HC times area. Okay, that is the area. Okay, just to note that for y sine theta is equal to h. Okay. Okay, and next we for force FR through the acting to the for force FR acting through the center pressure CP is not necessary to acting through the centroid of the area. You can look this for the FR is acting to the CP center pressure. Okay, so next, how can we know the location of the CP or center pressure? Okay, so we find by FR times YR is equal to integration of Y dF. Okay, and for this for integration of Y dF we substitute F, so we got like Y gamma H dA. Okay, and Y gamma we substitute H in this equation, we got sine Y sine theta dA, and finally we got gamma Y square sine theta dA. Okay, so that's what we got from this equation. Okay, and substitute FR in this equation, we can estimate YR. Okay, and then under this term of integration Y square over dA is what we call the second moment of the area. or moment of inertia that you learn from static. Ix is respect to x. Okay, and we can use the principle of the polar axis theorem. We can estimate moment of inertia around x-axis. Okay, you remind you about the the shape of rectangle shape. This okay. So this case the moment inertia at around the around x-axis passing the centroid is equal to this equation. Okay. And for the xa, moment of inertia around the x-axis is equal to xc plus the area times yc square. In this case, yc is equal to y over 2. This is half of the height of the rectangle, so we 1 over 12 moment of passing centroid 1 over 12 be y power 3 plus the by and y over 2 square. Okay, that is similar to what I'll just remind you what we learned the polar axis theorem from the static, so we can apply to hydraulics. Okay, that is the so we can prove that the moment inertia around the x-axis is equal to ixc plus ayc square, and ixc is the second moment of the area respect to the axis passing to the centroid and parallel to x-axis. Okay, and finally for y we can estimate, we can find the equation of the yr based on this equation. Okay, so it's equal to centroid of the passing through centroid along x-axis divided by yca plus yc. The resultant force of the hydrostatic pressure does not act on the centroid, but at a point lower than the centroid. Okay, so this just show the curve graph like this. This is yr, so this is yr. You can see that yr and centroid, yr is a little bit longer than yc. So in this case, you can show the gap between the length between yr and yc. So this length is equal to ixc yca. Which means if this value is greater than 1, so it means xyc is not the same point as xy is the larger than yc. Okay. Next for the xr. Okay, location of this resultant force on the x-axis. Okay, we can find based on the similar fashion that fx times xr is integration of x df. You can do integration, and this it can be cancelled. Okay, so we can prove that the xr is equal to xy divided by yca. Okay, and ixy is moment of inertia respect to x and y axis. And based on the principle parallel axis theorem, we can write equation of the xr is equal to this equation. xyc is the summation of inertia respect to the reference axis passing the centroid of the area. Okay, and the location of the force acting on inclined surface we call the center of pressure. Where is the xyc from this figure? So xyc is the different point of between this between xc and xr. get the distance between xr and xc is equal to I x y c divided by y c a. And again